Hello, in this session I will talk about what is big data. This is Hassan Mir from 02protraining.com. You must have already heard about the term big data. If not, then chances are you will hear about this term very soon, because this is the direction where the technology is going. So the question is, what is big data? The name is very misleading because the term big data gives you an impression that after a certain size the data is big, and below a certain size the data is small. Just to refresh your memory, these are the symbols to measure the size of the data. We deal with kilobytes, megabytes, gigabytes, and even terabytes on day-to-day basis. And if we go a little higher than that, then we have petabytes, exabytes, zettabytes, and yottabytes. And you can see here 10 to the power 15 is petabyte, and so on. So the question is, from what point onwards the big data starts? The answer is, it depends. The big data could start from any point. There is no definitive definition for big data. However, it is mostly defined this way, that big data is a data that becomes difficult to be processed because of its size using traditional system. Just to put things in perspective, let's say you have created a document of 100 megabyte and you want to share it with your colleagues, and you're unable to send it via email. So this becomes big data for you because you are unable to use traditional methods with this document because of its large size. And let's say you have an image file of 100 gigabyte and you are unable to display it on your monitor in real time because of the size of this image file. So this becomes big data for you in this context. And let's say you have a video file of, let's say, 100 terabyte and you are unable to edit it using your editing software. So this video file becomes big data for you in this context. So it depends on the capabilities of the system. So the term big data is relative to the capabilities of the system. At a higher level, the term is relative to the capabilities of the organizations. Let's say a stream of data is coming into two companies, company 1 and company 2. And let's say the data set consists of different unstructured items like text, audio, video, etc. and 500 terabyte is coming in on daily basis. So this data set could be a big data for one company and not the other. It depends on the capabilities of the company. So here we are assuming that company 2 is all set to digest this volume of data, this variety of data, and at this velocity, and company 2 is not at par yet. Traditional systems, including relational databases, are not capable of handling the big data, and challenges spring up at multiple levels, including the capturing, querying, storing, analyzing, searching, sharing, transferring the data, and even visualizing the data. The big data becomes a challenge for a traditional system not merely because of its size. That could be a challenging point, the size, but challenge may also arise because of the speed at which the big data is coming in, and also because it is unstructured and it could contain data items of various formats. So big data is usually measured by 3 V attributes: velocity, volume, and variety. The velocity refers to the speed at which the data is coming in. For example, the scientific experiments that they do at the atomic reactors, where they do the collision of subatomic particles, 40 terabytes of data could come in within 1 second. So that is a very high speed. Volume is of course a problem. The data keeps on getting accumulated and the file becomes too large to be handled by traditional systems. The Facebook is generating 25 terabyte of data daily, so just imagine the size of the files that are there since the beginning of time. In traditional systems, data is structured and it is stored in well-planned tables. Each table has specific columns, and each column could accept values of specific data types. However, in case of big data, the third V creates problems sometimes, and that is the variety. When the big data comes in, it may include items of variety of formats. It could have audio files, video files, unstructured data like text messages. So that becomes challenging sometimes for a traditional system to handle. The explosion of the big data is a very recent phenomena, and it is quite recently companies have started to realize that they should capture all this data that is being produced, and not only capture, they should try to analyze it and try to get some value out of it. These days the decision making is solely performed on structured data, which is mostly stored in applications like ERP and other related applications that are running in an enterprise. So most of this unstructured data gets wasted. It is not captured, and even if it's captured, it is not analyzed, and even if an attempt is made to analyze this data, real value is not extracted because of the limitations. This is the area, the 90% area, that represents the focus of the companies in coming years. You can call it a challenge or you can call it an opportunity, but this is where the focus will be. Companies will try to analyze this unstructured data and extract meaningful information out of it. So we have talked about big data, how to define big data, and what kind of challenges it is producing. But why suddenly we are talking about big data these days? Where is this big data coming from, and why it wasn't there before? At a very high level, growing number of users, applications, systems, and sensors are producing large and large files. These files are not only large, they are being produced sometimes at a very high speed, and sometimes these files contain variety of data items of different formats. So all these attributes are creating challenges for traditional systems, and hence the term big data. Here are some examples of the data generation points. The growing number of mobile devices, microphones, readers, scanners, science facilities, machine sensors including automobile sensors, cameras, social media websites, programs, softwares, etc. So all these are points where data is coming in at very high speed, resulting into large files, and sometimes the data is not even structured. We looked into the generation points, so this would be the actual data coming out of the generation points. We may have video files, audio files, images, photos, log files, click trails, text messages, emails, documents, books, transactions, public records, etc. So these are the examples of the big data. Let's talk about some events that would result into big data. This will put things in perspective. 10 terabyte is generated every 30 minutes from an Airbus, so a typical flight will generate about 650 terabyte of data. That is a lot of data. Usually one big warehouse would be of this size. Then we have smart meters in houses these days that performs a reading every 15 minutes. So 350 billion transactions are recorded in a year. In 2009, there were 76 million smart meters, but by 2014 there will be 200 million smart meters. So look at the growth. Now let's talk about the camera phones. 5 billion camera phones are there worldwide, and most of them are location aware, meaning when you take a photo, the location information could go in the photo as well because of the GPS capabilities. And 22% of these phones are smartphones. By the end of 2013, the number of smartphones will exceed the number of PCs. The cell phones and smartphones are major players in creating large volume of data. Whatever you're doing over your cell phone, smartphone, and on the internet is being recorded as much as possible. So more than 2 billion people use internet. By 2014, Cisco estimates the internet traffic will reach 4.8 zettabytes per year. Talking about internet, there are about 200 million blog entries on the web. 300 billion emails are sent every day. RFID stands for radio frequency identification. These are the tags that go on most of the items that you buy from retail shop like Walmart to automatically track the movement of the items. In 2005, there were about 1.5 million RFIDs, but in 2012 there were 300 billion, and Walmart has played a major role in increasing the number of radio frequency identifications. Facebook, Twitter, LinkedIn, these are all the companies that have to deal with the big data problem sooner than later, and they are already doing a reasonable job, otherwise they won't be in the business. Facebook generates 25 terabyte of data daily, and there are 1 billion active Facebook users. Twitter generates 12 terabyte of data daily, 200 million users generating 230 million tweets daily. 97 tweets are sent per second, just to put things in perspective. Talking about YouTube, 2.9 billion video hours are watched on YouTube per month. Big data is also coming from activities like trading. New York Stock Exchange produces 1 terabyte per day. Scientific facilities like atomic reactors, where they break subatomic particles, could generate data up to 40 terabytes per second. That is a lot of data. So in short, in 2009, the total data was estimated to be 1 zettabyte. In 2020, it would reach 35 zettabyte. 35 times growth of data just in about 10 years. When defining the big data, we use the term traditional system. Relational databases are a good example of a traditional system, but there are other software as well that make up the traditional system. And you can see, after going through all these examples, there is an explosion of data, and traditional system is not ready to handle all that. Even relational databases like Oracle are not scalable enough to handle the enormous size, variety, and the speed of data coming in. Because of these limitations of the traditional systems, the term big data has entered the scene as a problem, and this problem has been accepted by the industry, and now we have started talking about the solutions. And there are tools that have been created to address the problem of big data, and we do not call those tools traditional systems, we call them big data tools, and Hadoop is one of the best examples of the big data tools. Big data tools like Hadoop work very differently. They break the big data down to smaller pieces, and they break the computation down to smaller pieces as well, and each smaller piece of computation is sent to the small piece of data, so that instead of performing one big computation, numerous smaller computations are performed, obviously much faster, and finally the result is aggregated, and the aggregated result is then sent back to the application. I have talked in detail about how Hadoop works and how this technology was developed by Google and later on adopted by Yahoo and then handed over to Apache under the umbrella of Hadoop. So what we will be seeing in coming years, companies will try to capture this 90% unstructured data that is being wasted. Not only capture it, they will try to analyze it, and they will try to understand it, and they will try to get meaningful information out of it to create an edge over competition. And governments want to use big data to forecast events like unfortunate events, civil unrest, spread of diseases, so on, so that they could take some proactive actions. In order to get a value out of big data, it has to be collected. That is a challenge itself. Then it has to be analyzed and then finally understood. This is where the value will come from the big data. In order to analyze the big data, interconnectedness has to be established among different pieces that have been captured, and the challenge there is all these pieces are in a different format. The data is unstructured, so that's why we need a new breed of software to handle all this, and we call it big data tools. So in short, the big data is the topic for the coming years, and this is where the focus will be for most of the companies, and this is where the demand would be in the job market. So this slide is from a Hadoop presentation. This is showing the number of jobs related to Hadoop, and Hadoop is a big data tool. So this gives you an idea of where the direction is.